Hello, this is Ryan from Physmatics and welcome back to episode 5 of our Math SAT Prep series. In this video, we are going to complete Math Module 1 from Paper Practice Exam number 1 on the College Board website. So if you're unfamiliar with our series, we are going to go through each of the paper practice exams that are publicly available on the College Board website. You can find the link to those in the description of this video. And we're going to go through each of the 6 available math exams. We're going to go through each math module until we've answered all of the questions that are available on College Board's website. So today we're going to complete Module 1 from practice exam number 1. So let's jump right into it. Question number 22 says the measure of angle R is 2 pi over 3 radians. The measure of angle T is 5 pi over 12 radians greater than the measure of angle R. What is the measure of angle T in degrees? So they give us some measure angle R, and they give us some other measure angle, well, they don't give us angle T. They tell us that angle T is 5 pi over 12 radians greater than angle R, and then they ask us for angle T in degrees. So what we're going to have to do is we're going to have to figure out how large angle T is in radians, and then we're going to have to convert that to degrees. So if angle T is 5 pi over 12 radians greater than angle R, then what we're going to do to figure out angle T is we're going to take angle R, which is 2. We can do better than that. We're going to do 2 pi over 3 radians plus 5 pi over 12 radians. And if we add these together, we should find the number or the measure in radians for angle T. So let's do that first. Whenever we are adding fractions, we need common denominators. So, whoops, we zoomed out way too far there. We just want to zoom maybe like this is cool. So I need common denominators. So how am I going to get common denominators? Well, I'm going to look for the least common multiple between 3 and 12. It happens to be 12. So if I want to turn my denominators over here into 12s, I should multiply by 4 over 4. Remember, I am not changing this fraction when I multiply by 4 over 4, because 4 divided by 4 is just 1. And if you multiply any number by 1, it will remain unchanged. So I'm going to change how this fraction looks, but I'm not changing its value. So 4 times 2 pi is going to give me 8 pi over 4 times 3 is 12. So now I know that angle R could also be expressed as 8 pi over 12 radians plus the 5 pi over 12 radians that I need to add to get me the measure of angle T in radians. And of course, 8 pi plus 5 pi is 13 pi over 12. So now I know angle T in radians is 13 pi over 12. Now, if I want to convert from radians to degrees, I should multiply by 180 over pi. And if you're confused about converting between radians and degrees to radians, I think of it like this. Radians are going to have a pi unit in them, while degrees aren't. So if I want to convert to degrees, I'm going to multiply by 180 divided by pi so that I can take the pi in the numerator of my radians unit, and I'll take the pi into the denominator over here, and I'll be able to cancel them out. If you want to convert degrees into radians, you're going to take this guy over here and flip it to pi over 180. And that way, you'll end up with a pi unit in your numerator. So that's how I like to remember the formula. But you can use whatever device for memory works for you. So, like I said, if I'm going to multiply by 180 divided by pi, I can reduce to 1. Pi divided by pi is going to be 1. And so now I'm just left with 13 times 180 divided by 12. Alrighty? So I should be able to pull up my calculator. So let's pull up our calculator and do 13 times 180. 13 times 180. And we'll divide it by 12. And that is 195 degrees. So that looks like answer choice C. Alrighty, so that's question 22. Let's clean this up, give ourselves some space, and let's look at question 23. So 23 says a certain town has a area of 4.36 square miles. What is the area in square yards of this town? And then they give you the conversion. 1 mile is equal to 1,760 yards. So a mistake that some students might make would be to take the number of square miles and multiply it by the number of yards. But you have to be careful because they're giving us, these units don't match up, right? They're giving us square miles, and then they're telling us that 1 mile, not square miles, is 1,760 yards. So let's draw a square. That is a rectangle. Let's see if we can't make it a square. That's pretty darn close. There's a square. Okay. So what I want to do here, right, if this is 1 square mile, right, remember the area of a square, area equals side times side, or side squared, which is where the term square can come from. So if this is 1, if this has an area of 1, if this is 1 square mile, then each side would be 1 mile long, right? 1 times 1, or 1 squared, is 1. So let's figure out, though, how many square yards there are in 1 square mile. So let's draw another square. Maybe we can copy this one. And this time, instead of writing the units in miles, let's convert it to yards. Well, if 1 mile is 1,760 yards, then the other side, or another side of this square, would also be 1,760 yards. And the area of the square in square yards, area, is equal to side squared, or side times side. So my area is going to be 1,760 yards squared. So let's pull up our calculator. Again, these are calculator acceptable questions. And we're going to take 1,760 and we are going to square it. And okay, big number, but this is how many square yards there are in 1 square mile. And that would be 3,097,600. But we are not dealing with, let's see, we're not dealing with a town that is 1 square mile. We are dealing with a town that is 4.36 square miles. And we want the area in square yards. Well, I know already on my calculator that there are 3,097,600 square yards per 1 square mile. So if I have a town that is 4.36 square miles, I'm going to take my number of square yards per mile and multiply it by the number of square miles that we have in our town, 4.36, and I get 13,505,536 square yards in 4.36 square miles. So that looks like answer choice D. Moving on, we have number 24. They give us an XY table, and they say that there's some line H, or for line H, the table shows 3 values of X and their corresponding values of Y. So put simply, they have some line H, and these are 3 points that lie on that line. Line K is the result of translating line H down 5 units in the xy plane. So what is the x-intercept of line K? Okay, so what we need to do here, if we want to find the x-intercept of line K, is first we have to figure out what line H looks like. And I can do that by using the coordinates that they've given me. Alrighty? In this case, it might make sense to use point slope form for a line. Alrighty, point slope form should be y minus y1 equals m times x minus x1. And the reason that I'm using point slope form is because they're not showing me the y-intercept right now. They're giving me points. I can use 2 of these 3 points to find the slope, and then I can take one of these sets of coordinates and plug it in for y1 and x1, and I can find the equation for my line that way. And we can convert it into slope-intercept form if we like. So let's first find ourselves the slope. So let's choose 2 points to use to help us find the slope. So why don't we just make life easy for ourselves and choose these 2 points right here. Remember, slope is always equal to change in y divided by change in x. Okay, well, between these 2 points, how are the y's changing? Well, I'm going from 160 to 178. That is a change of 18 units. Great, my change in y is 18 units. Well, what is the corresponding change in x over those 18 units? Well, we go from x is 23 to x is 26. That is a change in 3 units. So we move 18 units on the y-axis for every 3 units we move on the x-axis, and if we simplify that, it looks like we have a slope of 6, meaning for every 1 unit on the x-axis that we move to the right, we should be moving up 6 units on the y-axis. So great, we can find ourselves an equation for a line now, right? I can choose any one of these 3 points, and I can plug them into my formula. I can plug the x value in for x1 over here on the right, and I can plug the y value in for y1 over here on the left. So why don't we just use the very first point, and we'll use our slope. We know the slope, we calculated that, and we'll get ourselves an equation, right? So this equation could be y minus, well, y1. Well, the y coordinate in the coordinate pair I have circled is 130. So y minus 130 is equal to m. We know our slope is 6 times x minus x1. Well, our x coordinate is 18. So here in point slope form, called point slope because we built this equation using a coordinate point, and the slope is an equation for a line. Now, if you're like me and you prefer to work in slope-intercept form, we can convert this to slope-intercept form. All we're going to do is distribute the 6, right? And we're going to then add 130 to both sides, right? I can add it out here, 130. And these will eliminate for us, and we'll have a line in slope-intercept form that is just y equals, we were supposed to distribute our x over here, so 6 times x is 6x. 6 times 18, well, if you want to do this in your head, 6 times 8 is 48, 6 times 10 is 60, and 48 and 60 is 108. So we have 6x minus 108. If you didn't follow that, we took the 10 from 18 and the 8 from 18, and we multiplied them by 6 separately, and then we added them together. And then, of course, we added 130 to both sides. And so my line in slope-intercept form is going to be y equals 6x, let's draw it better, 6x, and negative 108 plus 130 should be plus 22. And remember, you have your calculator available for this part of the exam. So again, if you don't like doing mental math, just rely on the calculator, right? You can distribute your 6 here, add 130 to both sides. You can do it all on the calculator, and you should still end up here. Now, next, we have line H, right? We just built line H. We built it using some of the coordinates that they gave us from the table. Now, what they're actually asking us about is line K. And line K is the result of taking line H, so taking this line that we just built, and translating it down 5 units. So if you don't remember your transformations, a downward shift would look at like y equals f of x. If I have some function, I want to subtract 5 from the end of the function, not from the x value, but from whatever the y value is going to be, right? So if I have some input x, and I plug it into my function and I get some final y value, whatever that y value was, I want to subtract 5 from it, and that will help me shift my line down 5 units. So for all the same x values on line H, line K will have y values that are 5 units smaller. So why don't I go ahead and do that? If this is my function, f of x, we can do better parentheses than that. If this is my function, f of x, and I want to shift it down 5 units, once I have plugged in for x and found a y value, I should subtract 5 from that, right? So my new line is going to be y equals, well, if I want to subtract here are your like terms, okay? So y equals 6x plus 22 minus 5, which is 17. So if this was line H, this one has to be line K. It is line H, and we've shifted it down 5 units. Last but not least, we actually want the value of the x-intercept. Well, where is the x-intercept? Think about your x-axis on a coordinate plane. Let's draw in a quick coordinate plane. The x-intercept is where your line is going to cross the x-axis. And if I think about my x-axis, right, it has all different x-coordinates as I move left to right, right? I have all different x-coordinates, but you'll notice everywhere on the x-axis has the same y value, which is 0, right? Remember, y measures up and down. Well, on the x-axis, I'm 0 units up and I'm 0 units down, right? So if I want the x-intercept, or the x value where this line crosses the x-axis, I can find it by solving for x when y is 0. So let's do that. If I plug 0 into my new line, 0 equals 6x plus 17, and then just doing some quick algebra here. Whoops, I don't know why I made a 16. I can subtract 17 on both sides, and I'll get negative 17 is equal to 6x, and if I divide both sides by 6, I will get x equals negative 17 over 6, which should give me my x-intercept value. And if I look, there it is, negative 17 over 6. That's my x-coordinate where we cross the x-axis, and then like I was saying before, the y-coordinate should be 0. Otherwise, it is not the x-intercept. So that is the answer for question number 24. It looks like we have 3 left. All right, so question number 25. Question number 25 says, in the xy plane, the graph of the equation y equals negative x squared plus 9x minus 100 intersects the line y equals c at exactly 1 point. What is the value of c? So what this tells me, right, is that if they're telling me I have some line y equals c, we can assume that c is going to represent some constant, meaning they didn't tell me y equals, they didn't give me an equation like this, mx plus b. They didn't give me some x variable, which tells me that the y coordinate on this line is always going to be the same. And when you have, let's draw in a coordinate plane real quick. If you have a line where the y coordinate does not vary based on x, that is telling you that you have a horizontal line. So maybe I can change colors here. Let's draw in a horizontal line, right? Y equals some constant c. So let's just imagine for a second that c is the number 6, right? Think about this line here. This could be the line. This could be the line. Y equals 6. And that is because for every x value, right? My x values change as I move left and right. So this could be x is 1, x is 2, x is 3. But the y value, if this is y equals 6, the y value is always the same. It's always 6, right, when I move left and right. So when you have y equal to some constant, we're talking about some horizontal line. All right, and what they're asking us for is they're asking us what is the value of this constant. So basically, at what y value does this horizontal line exist? And here are some of the other hints they give us. They give us this equation here, which is a quadratic. I know it's a quadratic because the degree, or the value of the highest exponent, is 2, meaning the shape that this function makes is a parabola. They tell us that this is going to intersect our horizontal line at exactly 1 point. Well, if you know about the shape of a parabola, you know that it is either this U shape or this upside down U shape, right? This particular parabola is going to open downwards. Oh boy, I want the eraser. Come on now. There we go. It's going to open downwards, and I know that because I can see that in front of my x squared I have a negative leading coefficient. So I know I have a parabola that opens downward. The only way for a parabola and a horizontal line to intersect exactly once is if they intersect at the vertex. So if I want to know what this constant is, and when I have a horizontal line y equals to c, this constant should be equivalent to the y value of every point on this line, right? And so that should be the same as the y value of the vertex of this parabola. So in other words, if I could figure out this vertex is at some coordinate that we don't know, right? Question mark, comma, question mark, I'll call it. We don't know the vertex right now. But if we can figure out the y value of the vertex, we will know what this constant has to be on this vertical line, because the y value of the vertex should be the same as the y value for every point on this horizontal line. So how am I going to find the y value of the vertex? Excuse me while I clean this page up a little bit. Well, to find the y value of the vertex, I could find the x value of the vertex, and I could find the x value of the vertex, and I could plug it into the function that I am given. And if I know the x value of the vertex and I substitute it into my equation for x, it should give me the y value of the vertex. Well, how do I find the x value of the vertex? Well, if you're familiar with your parabolas, actually, I can use the line tool here. You should know about something called the axis of symmetry. And the axis of symmetry is now a vertical line that, when drawn, will cut my parabola in such a way that the left-hand side and the right-hand side are symmetrical. Now, obviously, my drawing is freehand, so it doesn't look perfectly symmetrical, but if I had drawn a nice parabola, right, this vertical line through the vertex would make the left-hand side and the right-hand side mirror images of one another. In other words, symmetrical. So the equation for the axis of symmetry. The axis of symmetry must pass through the vertex on all parabolas, otherwise it will not cut the parabola in a place that makes it symmetrical. The axis of symmetry is always equal to x equals negative b over 2a. If y equals some constant gets you a horizontal line, then x equals some constant, and negative b over 2a is going to be a constant, which I'm going to show you. That's going to give you a vertical line, because again, the x values are always the same, so x is going to equal some constant regardless of what the y values are, and you can see the y values are changing as I move up and down this line. So where am I going to get these b and a values from? Well, if you know about the standard form of a parabola, then you know that parabolas are usually written as y equals ax squared plus bx plus c. So in this case, my b term should be 9, and my c term should be negative 100, and that makes my a term, the coefficient attached to my x squared, negative 1. So plugging into my formula for the axis of symmetry, I'm going to have x equals negative b, that would be negative 9, because my b term is 9, so negative 9 over 2 times a. In this case, a is negative 1. So the x coordinate of my vertex is going to be negative 9 divided by 2. And I know that because the equation for this vertical line here is going to be x equals negative 9 divided by 2. Alright, so if all the x values on this vertical line are x equals negative 9 divided by 2, and the vertex falls on this vertical line, then the x value of my vertex is negative 9 over 2, which is the same as negative 4.5. Now if I take this x equals negative 4.5 and I plug it into the equation for my parabola over here, it should give me the y value of my vertex. And if the vertex sits on this horizontal line where all the y values are the same, then I am going to know the value of this constant. So I need to plug negative 9 over 2, or negative 4.5, into this function, negative x squared plus 9x minus 100. So let's do that. Right? We want to do negative, and then my x value that I'm plugging in is negative 4.5. You can have a double negative. Don't let that scare you. So negative 4.5, whoops, let's try that again. Negative 4.5 squared plus 9 times negative 4.5. And I think we want to subtract 100 here. Yes, we do. Minus 100. Don't confuse your negative sign and your subtraction sign. And it looks like we have negative 60.75. That is my y value of my vertex. So now I have to look at my answer choices here. Do I see negative 60.75? I don't. So what I could do is I could hit math, and I could hit fraction on my graphing calculator, which will convert this into simplest form. And I don't see my answer choice, and that is because we made a mistake. And if you can catch it, good for you. That's awesome. This should have been negative 9 divided by 2 times negative 1 is negative 2, which makes this positive 4.5. Whoops. So we can fix that. We want to plug into this equation again. But we don't want negative 4.5s in there. We want positive 4.5s. So let's delete that. Oop. again. Let's see if we can't just delete out the negatives here. Delete. Nice. Delete. Now we've plugged in positive 4.5. We have negative 79.75. We turn that into a fraction. And we get negative 319 divided by 4. And I believe that's going to be an answer choice that we see here. Let's just bring zoom back up. Oops. There it is. Negative 319 divided by 4. Alright. So let's knock out 26 and 27 quickly and call this video done. Alright. So this one, we have a system of equations. It looks like they're giving us a system of equations, and it says for each real number r, which of the following points lies on the graph of each equation in the xy plane for the given system? Well, the first thing that jumps out at me here, right, if you were to try and solve this system, right, and find out, let's say, where these two lines cross, you might want to do something called an elimination. If you're familiar with the elimination method, that is when you take one of your linear equations and multiply it by some factor so that you can later subtract the two equations and get one of these variables to cancel out, right? So let's say I wanted to get my x variables to cancel out by subtracting these two equations. I could do that as long as my x variables have the same coefficient. Right now they don't. My x variable down here has a coefficient of 10. My x variable up here has a coefficient of 2. Well, I can get them to match so that they cancel through subtraction by multiplying my top equation by 5. But you'll notice when I do that, well, 5 times 2x is 10x. 5 times 3y is 15y. 5 times 7 is 35. So what does that tell me? These are actually the same equation. This line is the same. Alright, this line is just written where each term is a factor of 5 smaller than this one. Right? But if you were to graph these two things, these two lines would actually lie directly on top of each other. Right? And if you don't believe me, take both of these equations, you can pause the video and isolate y, turn them both into slope-intercept form. And what you're going to see is when you subtract 2x and divide both sides by 3, you're going to get the exact same equation as if you subtract 10x and divide both sides by 15. They are the same line. So what does that mean? If I look back at the question and it says for each real number r, each of the following points lie on the graph of each equation, or which of the following points lies on the graph of each equation in the xy plane for the given system. Well, this is the same line. So I don't need to go and check all these points and find out which one satisfies both equations because this is the same equation. I just need to plug these answer choices into one of these equations and find the one that works. Okay? And it's impossible to solve this system of equations and match one of these answer choices here because these are the same line, there's infinite solutions. So algebraically, I'm not going to be able to find one of these answer choices using the elimination method, but I could substitute. All right, so that's what I would do. I would substitute all 4 answer choices in, and I would find the one that works. So maybe let's start with answer choice A, and we will work our way down. So let's plug into our first equation, right? That one looks pretty simple. So we're going to do 2 times x plus 3 times y and see if it gives us 7. So 2 times x. Well, the x coordinate here, it's funny looking, right? But just plug it in. R divided by 5 plus 7 plus 3 times y. Now what is y? It's negative r divided by 5 plus 35. And that should equal 7. So let's see if it does. This is going to give me 2r over 5 plus 14 by distributing my 2, plus, let's see, over here, 3 times negative r is going to be negative 3r over 5, plus, let's see, 35 times 3 should be 115, and that needs to equal 7. 2r over 5 plus negative 3r over 5 is negative r over 5, and 14 plus 115. Really, all we need to know is this is not going to equal 7. So answer choice A, not going to work for us. So we need to keep looking. Let's keep looking. Let's go to answer choice B. Let's see if this one works. So this one's also a funky answer choice. Don't be intimidated by it. Just take the whole x value, plug it in, and we'll worry about simplifying after. So we need to do 2 times the x value. So again, that's 2 times, this one is 3r, negative 3r over 2 plus 7 halves. And the y value looks like it's just r, so we're going to replace y with r plus 3 times r, and we're going to see if this one equals 7. So let's see. When we distribute this time, negative 2 times negative 3r over 2 is negative 6r over 2. 2 times 14 over 2, or sorry, 2 times 7 over 2 is 14 over 2. So when I multiply that out, that's going to be plus 3r equals 7. And this one looks like it's going to work, right? If I keep simplifying, negative 6r divided by 2 is negative 3r, plus 14 divided by 2 is 7, plus 3r equals 7. If I combine my like terms on the left, negative 3r and positive 3r cancel each other out, and I'm left with 7 equals 7. That is a true statement. That means this set of coordinates worked in the first equation. If they work in the first equation, they're also going to work in the second equation, because we already proved that these two equations are the same. And so it's got to be answer choice B. So we can cross all this out now, because I want to give us room to do question number 27, which is the final question in module 1 for practice choice, or for paper practice exam number 1. So let's check it out. Number 27. The perimeter of an equilateral triangle is 624 centimeters. The height of the triangle is k radical 3 centimeters, where k is a constant. What is the value of k? All right, so whenever we're dealing with some kind of geometry problem like this, I like to draw a triangle. So let's do our best to draw an equilateral triangle. So let's call this an equilateral triangle. What do I know about an equilateral triangle? Well, on an equilateral triangle, all 3 sides should be congruent, which means they're the same length. Okay? And if they're giving me a height, that's going to be an altitude that drops from one of these vertices down to the base. Alrighty. And what else do I know? Well, I know that if I have an equilateral triangle, you should know that the angles inside a triangle all add up to 180. And so an equilateral triangle has 3 equal sides and 3 equal angles. So these angles are all 60 degrees. So the last property then is, if I have a height or an altitude that drops from one of these vertices down to the side across, right, it's got to cut, it's going to end up cutting this side into 2 equal chunks, right? So when they tell us that the perimeter is 624 centimeters, that is their way of telling us how big each side is. If I take my 624 centimeters and I divide that by 3 equal sides, let's find out how big each side is. 624 centimeters divided by 3 equal sides. Each side is 208 centimeters. So that gives us some important information. As soon as this calculator, there we go. Okay, so this I know that each side now is 208 centimeters. This is 208. This is 208. And then if I have 208 across the bottom, but this altitude here splits it in half, then I know that this side is 104 and this side is 104. Additionally, another property of equilateral triangles, if I drop an altitude from this vertice down to this base, it is going to create a 90-degree angle. You can even see it looks perpendicular here, right? So what kind of triangle is this? This is 90 degrees here. Let me highlight. This is 90 degrees down here. This one, if I'm just going to look at this triangle here, right? This angle in here has to be 30, right? Because if each angle was 60, this is going to be an angle bisector, right? This is an equilateral triangle and I dropped an altitude straight down. So that should split this thing in half. So this little angle in here is 30, and then this has to be a 60-degree angle because it's one of the 3 angles that make up the bigger equilateral triangle. And so now I'm going to be able to do some right angle math here, right? They told us that the height of the triangle is k radical 3. So let me try and draw that in as neatly as I can. Here's k radical 3. Alright, if they want us to solve for k, we can do that because we know that because this smaller triangle in here has a 90-degree angle, it is a right triangle and it is subject to the principles of Pythagorean theorem, which is a squared plus b squared equals c squared, where c is going to represent the hypotenuse side. The hypotenuse side is always across from the 90-degree angle. So my hypotenuse has got to be 208 centimeters, right? So I'm going to plug that in for c squared. All right, a squared can be one of these sides and b squared can be the other side. So let me plug those in. Let's erase, give ourselves a little bit of space. Let's say that this is my side A, so that should be 104 centimeters. I'll square it, plus side B is going to be k radical 3. I'm going to square that too. And now I'm just going to solve for my constant k. Alright, it's going to lead to some big numbers here. So first I need 104 squared. 104 squared. That gives me 10,816. Don't be afraid of big numbers on the SAT. Alright, we're just going to wait for the calculator to clear out here. Whoa. Oops, I already forgot what that answer was. 10,816, so I have 10,000, maybe we'll move down here. 10,816 plus, this part we can do in our head, k squared is just k squared. The square root of 3 squared is just 3, so this is going to end up giving us 3k squared equals, now we need 208 squared, 208 squared. That's going to give us 43,264. So equals 43,264. And now we're just going to solve for k. So it looks like I have to subtract 10,816 from both sides. And I'm going to get 3k squared equals, this should be, let's do some subtraction. We're going to do this minus this, and that gives us 32,448. We know in the next step we're going to have to divide both sides by 3. Right, so 32,448. Again, we have to wait for the calculator to get on out of the way here. We said that that was going to be 32,448, and if we divide both sides by 3, we have k squared equals 10,816. 10,816. And now we are going to take the square root of both sides. The square root of 10,816 is 104. So there you go. Let's minimize this, and we should end up with 104. 104 centimeters. Nice. All right. So that is the entire first module on the first publicly available paper practice exam. If you'd like to book a one-on-one SAT tutoring session, remember you can go to physmatics.com. The link is in the bio for this YouTube channel, and you can always book a one-on-one tutoring session either with myself or one of the other math teachers that we have on staff. I hope you enjoyed the video. Make sure you stay tuned for episode 6, where we start module 2 of public practice exam number 1. Thanks. Bye.